Okay, I know we rushed through this in some of the classes, or maybe you just need some further clarification. So I'm going to go over the example problem again one more time. So with this, what we're going to do is we're going to look at our numbers and see what we know. We know that the pressure at the start is 2.5 atm. The initial temperature is going to be 306 Kelvin, and the final temperature is going to be 273 Kelvin. What it's asking me to figure out is what would the pressure be. So with this, I know that I'm working with pressure and temperature. That lets me know that my volume and number are remaining constant. Why is volume constant? Well, it's a rigid system. Why is number constant? It's a closed system. So, with this, I'm going to put my numbers in where I have them. I'm going to go ahead and write my units at the top of the columns because these boxes are pretty small and I don't want to have to stick them in there with my numbers. And this way, if they're at the top, that means everything in the column is assumed to have those units. With my initial pressure, it's going to be 2.50. Yes, you must write the 0 because digit of estimation. My initial temperature is 306 Kelvin. My final temperature is 273 Kelvin. So, since I'm working with temperature and pressure, we can go ahead and do our graphical relationship. We know that temperature is going to be our independent, pressure is going to be our dependent. We know that there's a direct relationship. As the temperature increases, the pressure increases. As the temperature decreases, the pressure decreases. So, when I look at this, my initial temperature was 306. My final temperature is 273. That means that my temperature over the course of this scenario decreased. Since my temperature decreased, and because of my graphical relationship, I know that pressure also has to decrease, even though I don't know what the final temperature is. And the reason for this is because with a lower temperature, we have less kinetic energy, which means less particle velocity, which means less number and force of collisions, and that, therefore, remember our 3 dots is therefore we have less pressure because the number and force of collisions is the measurement of, pressure is how we measure the number and force of collisions. So, if you've set everything up this far, the math becomes really simple. What we're going to do is we're going to start with our given. So we've got 3 numbers and you're probably wondering, well, what's our given? The given is always going to be whichever one has the question mark in it. So in this case, it's going to be our ATM because the question mark is going to be our 1. So 2.50, don't forget your units, over 1. Because remember, our given always starts over 1. So our ratio is going to be with similar units, meaning that our ratio in this case is going to be kelvins over kelvins. So now all we need to figure out is which one goes on top, the 306 Kelvin or the 273 Kelvin. And that's where our table comes in handy. I noticed that my temperature decreases, and so I said that when my temperature decreases, my pressure also has to decrease. So I know that this 2.50 needs to go down, it needs to decrease. So what type of ratio do I need for it to decrease? Do I want to multiply it by a ratio greater than 1 or a ratio of less than 1? A ratio of less than 1 is going to give me a decimal, and so that will make my number smaller. So I'm going to go with a ratio of less than 1. Well, how do I get a ratio of less than 1, or how do I get a decimal? Do I take my large number and divide it by my small number, or do I take my small number and divide it by my large number? Hopefully you said we're going to take our small number, the 273 Kelvin, and divide it by the large number, the 306 Kelvin. That's going to give me a decimal for my ratio. Then what I'm going to do is I'm going to go ahead and plug it in my calculator, and when I do that, I get an answer of 2.23 ATM. Again, I can check myself because I know that my pressure should have decreased based on my table above. My initial was 2.5 atm, the final is 2.23 atm. So that shows me that as temperature decreased, my pressure decreased. I did it correctly.